Translating assembly code to Python. In this video, we will look at machine language, and then we will examine the halt, load and store, add and subtract, increment and decrement, as well as the in and out assembly language instructions. Machine language is the binary codes built into the hardware of a particular computer processor and is used directly by the computer. Machine language is the only language that a computer understands natively. Higher level languages such as Python are translated into machine language before they can run. Every machine language instruction can be broken down into two parts: an opcode and 0 or more operands. The opcode specifies one low-level task. In our course, each opcode will be 4 bits long. The operands tell the opcode what it is that we're working on. In our course, all the instructions will have 0 or 1 operand. In fact, the halt command is the only one that does not use an operand. All of the other instructions we use will have 1 operand. Every machine language opcode has a corresponding assembly language mnemonic. We'll be using assembly language for the rest of this video. Here is a list of the opcodes and the mnemonics that we use in our course. In this video, we will examine load, store, clear, add, increment, subtract, decrement, in, out, and halt. We'll start with the halt. The halt command tells the CPU to stop running the program. You must have a halt command at the end of every assembly language program. The halt command does not change anything in memory. It does not change any of the registers. There is no corresponding Python statement for halt. The load command. The load command takes the contents of whatever we specify after the load. I have an X here, and that will always be an actual number. So we might see something like load 42. When we do, it'll take the contents of address 42 and place it into the register R. The load command changes the contents of R. We'll use the load command with other instructions to get our Python code. We're going to use the contents of R for several different actions. Think of R as a place to put a subtotal or to hold intermediate results. The store command will take the address specified here after the command. So if we say store 103, it will take the contents of R and put it into the memory address specified after store, in our example 103. The contents of memory address X is changed. So in this case, 103's content is changed. Whenever you see a store, that means you have a variable on the left side of an equal sign. So whatever we've done previously, whatever math we've done previously, B plus C, it'll take what is currently in the register R and store it into A. So let's look at how load and store work together. Load 100. Load 100 is going to take the contents of memory address 100 and put it into R. So right now, we have a 42 in location 100. So it's going to go into R. So the current contents of R goes away, and we replace it with 42. Our next line of code, store 101, will take the contents of R and put it into 101. So 101 will change from 8 to 42. We then have a halt. So if we assume that memory location 100 is A and memory location 101 is B, we're going to load 100. We're going to load A, and we're going to store it into B. So B equals A would be the Python equivalent of this assembly code. Clear X. Whatever address we specify after the clear command, the contents of that address will be set to 0. It is the equivalent of some variable equals 0. Add X. Add X takes the contents specified after the add command and adds it to the current contents of R. Add X changes the contents of R. It does not change the contents of the address specified by the add. So let's see how that would work. Building on our earlier example, we now have 3 memory locations, 100, 101, and 102. Load 100. Well, we've got a 2 in memory location 100, so it's going to go into R. Add 101. We're going to take the contents of 101, the 8, and add it to what's in R. 2 plus 8 is 10, so we're going to get a 10 in R. Lastly, we're saying store 102. That will take the current contents of R and place it into memory location 102. Let's convert this to Python. Load 100. Well, if A is 100, we start with our A. It goes into the register. Add 101. 101 is our variable B. We add B. Store says we're going to take that and put it into a location. And 102 we're calling C. So load 100, add 101, store 102 would be the equivalent of C is equal to A plus B. Subtract is very similar to add. Subtract takes the contents of memory address X and subtracts it from the current contents of R. The contents of R is changed by the subtract. Let's do an example. Load 102. 102 has a 45 in it. So load 102 is going to take that 45 out of 102 and put it into the register R. Subtract 101. 101 has an 8. So 45 minus 8 is 37. So 37 would be in R. Store 100 will take what's in R and put it into location 100. So that 2 will change to a 37. Let's try to see what the Python looks like. Load 102. Well, C is our address at 102, so we're going to start with a C. Subtract 101. 101 is B, so it's C minus B. Store 100. We're going to take that and put it into A. A is equal to C minus B is the equivalent of this short assembly language program. Increment X. The increment command takes the contents of the address specified and increases it by 1. The contents of the memory address is changed. So if A was at 100 and we said increment 100, it would be the equivalent of A is equal to A plus 1. Decrement. Decrement takes the current contents of the address specified and decreases it by 1. The contents of the memory address X is changed. In is the equivalent of the input. It waits for the user to type a value at the keyboard. It takes the value that the user types and puts it at the memory location specified. So if we had in 101, where 101 is B, it would be the equivalent of B is equal to input. The out command is similar to the print. It takes the contents of X and displays it on the screen. The out command does not change anything. So if we had the instruction out 102, and 102 was address C, it would be the equivalent of print C. Let's take a look at a slightly more complicated problem. Load 100. We're going to take the value that's in memory location 100, which we're saying is A, and putting it in the register. Add 101 is going to take the value that's stored in 101, B, and add it to the current value in the register. Subtract 102 is going to take the contents of our variable C and subtract it from the current value in the register. Store says we're going to take what's in the register, all of that, and put it into 103, variable D. Out 103 says print D. And then we hold. That's it for this video. The next video is Translating Assembly Code to Python, Part 2. If you have any questions, please speak to me.